If anyone is having any problems connecting in any way, feel free to send us a chat through the chat interface. Once again, this is Kevin from PCI, and we're going to be starting in just about 1 minute. All right. Well, it's a pleasure to have you join us today. My name is Kevin Jones. I'm the Director of Marketing here at PCI, and I'd like to quickly give you an overview of what we'll be covering today. The webinar is entitled Ortho Mosaicking with Geomatica. We will be talking a little bit about our technology in general. We have other technology in addition to Geomatica to perform large-scale mosaics. We will be covering essentially how to use our new advanced Ortho Mosaicking technology to produce stunning results with imagery of varying sort. So we have satellite imagery, aerial imagery that can be used for Ortho Mosaicking, and hopefully what you'll get out of this webinar is a sense of the impressive color balancing that can be completely automated. We have a end-to-end workflow which includes everything from color balancing, cutline generation, editing, and we've got some great new functionality for dodging point editing and automatic exposure correction and post-mosaic editing. So if we go to the next slide. Just a few things to get out of the way, not too long on this. You are going to be muted during the presentation. You can raise your hand if you want to get our attention. You can send us a chat question through the questions panel. And we will be recording all of this. So if you want to come back and review anything, you will be sent an email with a link to the recording. Just a few words about ourselves. I'm on the right, Sean's on the left. Sean is standing by and is going to be giving the technical part of the presentation today. Myself, I'm the Director of Marketing here at PCI. I've been with the company for about 6 years now, and I hail from the geospatial industry. I'm a remote sensing application specialist originally, and it's a pleasure to be working here at PCI and presenting to you our great technology that we have available for performing multiple tasks, including Ortho Mosaicking. Sean has been a colleague of mine here at PCI for the same amount of time as I've been here. We actually started roughly at the same time, within a few days actually. And he's a technical solutions specialist. So Sean is a wizard with all of our technology, and he is very passionate about seeing our customers get a great amount of success using our tools for solving geospatial image processing challenges. So just a few quick words about our technology. If we just advance so we can have everything displayed here. So we like to refer to our technology as a platform. We have a very flexible and scalable platform that allows you to achieve a lot of automation and across different size projects. So we have desktop software, we have automation capability with our Python API, and we have a high volume production capability known as GXL. And this technology scales up and down. You can add multiple seats of Geomatica if you prefer to have multiple people working on your project, or you can achieve automation using completely automated systems such as GXL for really grand scale automation. You'll see a really stunning mosaic in this presentation coming up that was produced by one of our partners in Mexico. and they've made a complete mosaic of all of Mexico using our GXL technology, which is really impressive. Next slide. So we have very scalable mosaicing solutions, and this makes it very easy for you to use our technology and to achieve gains in your production capacity. So I'm going to ask Sean to display the mosaic of Mexico to really give you a sense of how impressive this is. This is a live map that you can actually look at. We'll be sending the link around, and Sean's just going to be zooming into a few different areas here. And this mosaic is made up of roughly just under 10,000 individual images collected by RapidEye, the RapidEye constellation. And immediately what you see with this mosaic is the absence of any clouds, which was achieved by selecting the best images, the seamless colors across the very varying terrain, and just the sheer beauty of it. This is an amazing mosaic that has been produced by Canabio, which is our partner in Mexico, and they were able to do this using our GXL technology, and really, to achieve this scale of project in a reasonable amount of time, they were able to do that using our image processing technology that's made available through GXL. Now, these same types of results can be achieved at different scales with Geomatica, and what we hope to show you in this webinar is how that can be done with the tools that Sean will actually be giving you a demonstration on. So at this point, I'll pass over to Sean, who's going to bring us into a demo portion of our webinar.
Muted.
All right, thank you very much, Kevin, for that wonderful introduction. So also just on the note of that mosaic very quickly, it should also be noted that this was also produced by a single operator using the GXL. So once again, really it was just a single operator doing all the processing using our GXL technology, because it's designed in a manner that allows for that kind of processing with a limited staff assigned to that particular project. So I want to focus more my attention on the specific features and functions and the workflow, our mosaicing workflow. And in this, we're basically going to cover a few different topics, and I'm going to provide a live demonstration of an end-to-end workflow at the end of this, after I go through this PowerPoint presentation here. So basically the key features that we're going to be looking at include our new color balancing algorithm called Bundle. We have also our automatic cut lines. Once again, cut line or editing. We're also going to introduce you to our new edge and floating dodging points. We have a new automatic exposure correction algorithm, and our smart GeoFill for performing post-mosaic editing. So our new color balancing algorithm is designed in such a way that it's meant to handle various scales of imagery with variety of land cover types and produce a very seamless result. And basically, just to show you a little bit more about the quality of this algorithm, I'm going to bring up here just a quick few mosaics that we put together. So here we have an air photo result. So this is before and after of our air photo. So you can see that we have significant improvement along the seams between across the different strips. And then we have, for example, a ComSat scene. So this is with no color balancing applied. And then afterwards, if we take a look, this is the result we get when we applied our bundle method. So very seamless result. Once again, for larger scale projects, such as countrywide, such as Canada, we produce this Landsat. So this is the result from completely automated processing. So this also, one of the benefits of this result, as you can see on your screen now, is the fact that it covers a variety of different land cover types. But one of the other big benefits is not only does it help to ensure good color balancing between scenes, but it also helps to preserve the natural color of the images, or the color fidelity as it's known. We have another scene here, RapidEye, North Korea. So once again, you can see the beautiful colors that are preserved due to this color balancing approach. And then finally, we have a multi-sensor mosaic, which is Worldview 2 and GOI of the Toronto area. Okay, so I just want to quickly show you some of the results there. And now we're just going to continue back in. So I want to explain very briefly about this color balancing approach. So to best describe this approach, it's better to look at some of the traditional methods that's used as a baseline. So traditional method, when looking at color balancing, is we generally set a single set of coefficients to help calculate the brightness and contrast for each color band in order to achieve good color balancing. Now the problem with this approach is it usually ends up in generating what's known as or what we affectionately call a checkerboard effect. And this is where we get some images that balance well to each other, whereas they don't necessarily balance well to all their neighbors. And then this can be very challenging and very time-consuming to manually edit. Now the other downfall about this approach, because we're adjusting the entire image up and down to meet the color balancing requirements of its neighbors, we have the ill effect of also sometimes producing an unnatural looking image. So to counter this, we came up with a brand new algorithm and a brand new concept known as bundle, which sort of mimics the block bundle adjustment known in photogrammetry. And what we do here is we actually calculate a set of coefficients for each cut line that's connecting different images, different neighbors, and therefore we try to balance just the edge areas and then blend those results out. And that's what helps us achieve not only better balancing as we're really focusing on just the particular edge, one at a time, and each edge is being treated differently, it also minimizes the amount of changes we need to make to the image pixels, therefore maximizing the natural image quality. So now also just to quickly go through, we have some additional mosaicing tools and features, so such as edge dodging points for fixing the colors along the edges themselves. We have floating dodging points for performing localized edits within a particular image. We also have the new automatic exposure correction tool, which is used to remove the brightness of overly bright areas, therefore improving the contrast and details in these areas without negatively affecting areas that are darker. And then our smart GeoFill, which allows us to basically perform post-mosaic editing. For example, image vetting, which is to, say, hide sensitive features, such as, say, this headquarters of a military headquarters over here. As you can see, we can easily copy and paste pixels in. And we can also perform, for example, post-edits such as removing clouds and shadows from other imagery, where we can apply color balancing approaches to those pixels directly. And it makes editing your mosaic after you've already generated it significantly easier. And then finally, we have our lookup table. So one of the requests is we have a very advanced lookup table editing tool. And one of the requests was to create a more simplified version, in which we did. So now we also have a simplified version that makes performing lookup table editing very easy and intuitive. So with that, I'm going to move now to our live demonstration. So before I go into the actual live demo, or as I go into the live demonstration, I just want to show you the result that we want to produce. So we're going to be working with a downsampled set of Iconos imagery, which basically is going to be used, and the reason we downsampled it was just for the demonstration purposes, but we basically want to take this imagery, which consists of water, atmospheric constituents, a variety of different seasonal variations, and we want to produce a nice final mosaic where we have the most minimal amount of cloud cover that we can achieve with our current data, and also a very good color balancing with very natural looking results. So this is what we're trying to achieve here. Now in order to do this, we're going to bring up Ortho Engine. So our starting point in this demonstration is going to be ortho images. So we're starting from having the orthos already produced. And once again, our tools can be used to also generate the ortho images, but in this particular demonstration, we're going to start from the ortho images. So you would go to our mosaic processing step, and you'd first define your mosaic, so I've already done this. And then the next step, you can go to the final button here, and you're going to do our automatic mosaic color balancing. So we're going to set our color balancing to bundle, our cut lines to the minimum square difference, and we're going to set our blend width to 2 because we're working with a downsampled imagery. And in this case, we're just going to generate the preview. Now when I generate the preview, it's going to calculate the color balancing coefficients, it's going to generate the cut lines, and produce a preview mosaic that we can then go into our Ortho Engine tools and perform some editing around. So we can take this, I'm just gonna, oh wait, sorry, I need that. And now we can go into this button. So we just clicked on this one here, so we can now go into this button here, and we can add our images to our editing panel. So this is what's produced from the automatic mosaic editing tool, or the editing algorithms. So I'm going to now show you some of the different tools that we have that make editing very simple and easy and effective in order to get the final result that you're looking for. So we can see in this particular case, we didn't use a sorting order in order to make sure that our clouds go to the bottom. So we're going to and I did that purposely just to show you how easy it is to edit the cut lines. So we can select our cut line editing tool here, click on the cut line that we wish to edit, and then we can click on this reshape tool, as it's called, and we can just create a new vertex. And we're going to create now a new set of vertices as we go along this image, and just try to define it so that it goes around the clouds. So as you can see, we did a pretty good job here. Now the reason I didn't cut out all these clouds here is because there's some no data area underneath these clouds. I might be able to get just these ones. No, it goes into the no data area. So we're have to be, due to the lack of available data, we're stuck with at least some of these clouds here. So that's our reshape tool. As you can see, very interactive, very easy to use, very intuitive, and because we have a WYSIWYG viewer, you get to see your results immediately. So now a new concept that I want to introduce you to is our dodging point editing tools. So we're going to work on a particular situation where we have our image here. I'm sorry, just going to zoom in to an area. And I'm just going to put our cut lines back on for a moment. So you can see that if we look at our purple cut line here and the image that's to the right of that cut line, you can see that it's a little bit brighter than its neighboring image over here. So we have a discrepancy now in the color balancing. Now if we look at the image here that I just clicked on, which is to the right of the yellow cut line, and compare it with the image to the left of the yellow cut line, you can see that they have a nearly perfect, if not perfect, color balancing between the seam. So the challenge comes that how do we now correct this edit this seam line without negatively affecting our other seam line? So without dodging points, we would be required to adjust the entire image, say up or down, in order to achieve a good result between or around our purple cut line. But by doing so, we introduce an error now between our other cut line here, the yellow one. So we're going to undo that, and I'm going to show you the proper technique to do that with these new dodging points. So what happens is when we run the bundle color balancing, it automatically puts one dodging point on every unique cut line. So I can now select that dodging point. I can go to this tool here, and I can now increase, or I can use a scroll bar, whatever I wish. I can increase this using large steps or very fine steps in order to achieve the final color balancing that I want. So you can see now I've been able to, if you look here closely, I've been able to now effectively remove the noticeable seam between the right and left image of the purple cut line. Meanwhile, I'm not introducing any negative effects along the yellow cut line. So that is really the benefit of the dodging points. Now it gets even better than that. So I'm going to move up to an area. I'm just looking for it. Okay, here we go. So we have, for example, some situations where the color balancing may be even more localized than a single, or color balancing issue may be even more localized than with a single, along a single edge. It may be a specific segment along an edge. So as you can see here, if you look above the river, we have perfect color balancing. Below the river, we have perfect color balancing, but in the river itself, the color balancing did not turn out as good. So what we can do is we can click on this add a dodging points. We can add more dodging points. I can place one above, place one below, place one in between. And what I'm doing is I'm now setting boundaries for how far this one in between should extend. So I select the image that I want to change. I'm going to increase now the brightness of this area. And as you can see, it's only affecting the area around this one, and it does not go outside of these two boundary points. Might have been a little too high. And now I can use the fine one to get that final result that we're looking for. And then now I'm just going to click away from this, and you can see that we've significantly reduced and perhaps even removed this cut line or the seam line. And we can even do even more edits to get it absolutely perfect. So the last feature in the mosaic editing part that I want to show you is the floating dodging points. So say, for example, we have an image, say this one over the farthest one to the left, and there's areas within this image, not necessarily along a cut line, that are perhaps too dark. Well, I can add a floating dodging point to it, and then I can increase now, say, the brightness of just the pixels around it, and it blends in nicely to the surrounding pixels. Now I can even go once again beyond that, and I can set some boundary floating points. And now when I select this middle one, if I increase the brightness, say very significantly, you can see that it's constrained by these other floating points that are around it. So we can become very particular and detailed as to what we're going to change. And I can even go beyond that and say I want to make this area a little bit greener. Well, I can now say increase the green hue of this area in order to get the kind of result that we might be looking for. So it gives you a lot of flexibility to even help with some seasonal variations that may be affecting your mosaic. So once we're happy with this, we can simply select all of our images in the mosaic, click this Add Images to Mosaic button, and it's now going to generate and produce the full resolution mosaic. So we can now close this, and now we're going to show you some additional post-mosaic editing that we can apply. So the next one I want to show you, so we'll go to our output mosaic here, and what we can do here is basically the first step that I want to do is I'm going to run it through our exposure correction tool. So I can go to Tools, and I can go to Algorithm Librarian, and then the easiest way to find it right now is to go into New, and you'll see the desatur algorithm. So we can click on that. For the reference image setup, we're just going to select all input bands, and we'll select the same for the input image layers. The only reason we have these two parameters, they're not redundant. It's for when your mosaic is tiled. So this actually supports tiled mosaics, doing the same process on an output mosaic that has been tiled, which is a wonderful feature. So we're just going to put the view, we're just going to write it to the viewer or just store it in memory. I'm just going to change this to the overview level 32, which is the maximum overview level that we have in this image, and I'm going to run. Okay, so let's see what it's done. So if we look here, what we should notice if we toggle on and off is we can see that, say, certain areas, like I love this area up here, we go into, so in the before mosaic, you can see that these areas were, say, overexposed, and then afterwards, you can see that we've reduced and improved the detail of this area. The same thing is true in a variety of these other areas. So if we go down to here, same thing is true. We've improved the contrast and we've improved the detail of these areas without negatively affecting our darker pixels. And it's a fully automated tool that will go through and scan for these large overexposed areas within your mosaic completely automated. So now we can take this result, and I'm just going to save it out to file. So I'll call this exposure core. I'm just going to save it out to file. And we're going to do one last thing. So this is going to be a final post-Mosaic edit that we're going to do. So in the scenario that you basically, at the time of generating this mosaic, this was the best data you had for this area. And there's lots of clouds in there. But say after the fact, you were able to find an image that did not have cloud in this area. Either you purchased it or found in your archive, or even found a different sensor of similar specifications that you wish to use to fill in these pixels. Well, rather than having to go back in and regenerate your mosaic with this new image and do all those edits again, it's very simple using our smart GeoFill to basically correct for this. So I'm just going to remove this old one. So basically I can go into here, I'm going to go to, the first thing I'm going to do is right click on the area. I'm going to go to a new empty vector layer. I'll create a whole polygon layer. And I'm just going to put this one underneath. And I'm going to now draw a polygon that goes around basically the clouds. So we can even go outside of our mosaic. So you can see we went around there. And what I'm going to do now is I'm going to go to Tools, go to Smart GeoFill. And I'm going to change the source to our new ortho image, and the destination file is going to be the mosaic that we're currently working with. And I'm going to now copy the pixels. Now you can see I haven't pasted anything in, I just simply copied it, and it just copies the pixels inside our polygon. So I can now remove the polygon, and you can see the immediate problem that we've introduced is that, well, it doesn't balance well. Well, the good thing is that this tool includes color balancing options. So we can create a histogram one, for example. Now we know that there's some cloud there, so we should provide a bit of a tail trim to remove those outliers of the cloud. And then we're going to create a match width a little bit larger, so it's got some information to use for the color balancing. And we can apply, once again, we're applying this color balancing without actually pasting it in yet. And then when we're ready and we're happy with the results, I mean, I can try different ones, and we haven't pasted anything in. It's all in memory still at this point. But then once I'm overall happy with the result, I can then simply go paste. And it's going to paste the pixels in, plus apply a blending width, so that when we say go back to our vectors here and we say examine along a particular the vector, you will not see any difference between the colors. So we've now effectively brought in this new data without having to go through the hassle of regenerating our entire mosaic or even editing the preview mosaic. So it's it can be very useful for many other applications, such as removing buildings, sensitive buildings, so image vetting, amongst many other features. So basically with that, I'm going to pass the presentation back over to Kevin so we can basically close out the presentation with a couple simple poll questions. Thank you very much.
Unmuted.
Thanks a lot, Sean. That was a great demonstration, and I hope everyone has had a chance to type in their questions. I did notice some of you were typing in some very interesting questions, which we'll be getting to in a second. Just really quickly, before we go there, I will show you something that I think would be beneficial for you. So if you have any more questions about our technology and you want to see either a recording of this webinar or maybe even have a look at the videos, we do have a YouTube channel, and Sean has made a great series of videos here that you can refer to. So if you go to youtube.com/PCI Geomatics and you click on our playlists, there's a dedicated playlist for you to go through all of the demonstrations that Sean has given with a lot more detail. So I encourage you to check that out. And what I'll do next is I will launch a couple of polls. So the first one has to do with the actual content of the webinar itself. So essentially what we're asking here is whether you like the content of the webinar, if you have any comments or anything like that. We would love to hear it. We're always trying to make these webinars interesting for you, and we want to get some feedback on that. So essentially we're asking whether you think this is going to be useful for your existing operations, you see some value, maybe you don't think this is useful, or perhaps you think that the tools that you have now are suitable, and you didn't see anything that would cause you to think maybe about using PCI software. So I'm going to give that a few more seconds to come through. We've got quite a number of questions coming in, which is going to be very exciting in a few minutes here. So I hope you're ready, Sean. Okay, I'm going to close that poll now. Thanks very much for everyone who responded to that. One more thing before we get to the questions is we would like to know whether you thought this format, which was a little bit different than normally. We made a conscious effort to shorten the webinar and make it 30 minutes. As you notice, we're 1 minute past the hour right now. So let us know whether you think that was sufficient or whether you'd like to have more details. We'd like to know so that we can improve our webinars going forward. So give that a few more moments for people to vote on those. Looks like a 50-50 split. Some people love the 30 minutes format. Some people want more detail. So I'll just hang on a few more moments here before we close out the poll. All right. Thanks for everyone who gave us feedback on that. So we're going to go to the questions now. So I hope you're ready, Sean. There's quite a few, and probably you've got the questions panel up on your screen as well. So the first question that we had relates to the dodging point concepts and whether it affects. We've had several questions relating to what affects the dodging points and the manipulation of the various tiles has on the resulting digital numbers, whether that affects the resulting digital numbers, and if people are concerned about that, how would they handle that?
Yeah, so basically our mosaicing technique, the main idea behind this mosaicing workflow is to create a seamless, aesthetically pleasing mosaic. So yes, it does affect the DN values in terms of achieving a good match. The main purpose is not necessarily for further analytical analysis based on, if you're doing an atmospheric correction and the image, the true DN values or the radiance values are important to keep the fidelity of that, then you don't want to mosaic them using a approach like this. Mosaicing in that case, oftentimes you want to do more of like an atmospheric correction or image normalization technique that is based on some sort of physical approach, which we also have a lot of tools for doing that kind of work as well. But the main purpose about this workflow that we showed was more to create beautiful looking mosaics.
Great. We had a question about whether this feature comes with the existing version of Geomatica or the most recent version, and I'll take a quick stab at it, Sean. Maybe you can fill in the blanks, but all of the functionality that you saw in today's demonstration is in our latest version of our software, which is called Geomatica 2015. So if you want to try it out for yourself, you can download it on our website, and this functionality that you saw today is in there. Now, we did have some previous functionality in previous versions, but it just keeps getting better and better with the new versions. We have another question here about haze. So how would this work with regards to haze reduction as opposed to using atmospheric correction? Can you comment on that, Sean?
Yeah, so basically one of the ways that, if you have a satellite image, if you're working with satellite imagery and you have lots of haze, the fastest way to try would be to use our atmospheric correction haze removal. However, if you don't have that package, or perhaps you don't have a supported sensor for atmospheric correction, then the floating dodging points we found can be very effective at removing localized haze, but it's a bit more of a manual process.
Great. We've got a question here about whether this can be done with GXL, which, as I presented in the opening slides, is for processing much larger volumes of data.
Yeah, of course. So the GXL is actually, it's purpose-built to do large processing of, Ortho Mosaic processing. I mean, one of its probably its main application or its main purpose is for Ortho Mosaicking of satellite and aerial imagery, and it's designed to be a system-wide processing system, so it's meant for handling really large projects, such as projects greater than hundreds to thousands to tens of thousands of images, depending on whether it's satellite or aerial.
Great. Another follow-on question, I guess, or a related question to the types of data that can be used. We had one person asking about whether this technology could be used to improve the color balancing of multiple images collected by UAVs.
Yeah, of course. I mean, our mosaicing tools are pretty generic to imagery. So in terms of the specific to the mosaicing tools themselves or the mosaicing workflow, I mean, it can be used on really any imagery that you tend to throw out. I mean, obviously geospatial imagery. It's tuned for geospatial imagery, but generally speaking, yeah, of course, these mosaicing features can be used for really any geospatial imagery.
Great. Well, that's about all the questions we have time for. There were a few other ones, but I think we covered most of the topics that were asked. If the last call for questions, if anyone has anything they want to ask, if you'd like us to unmute your line and you would like to talk to Sean directly or myself, you can raise your hand or give us a quick little message. We can do that. We'll just wait a few more minutes to see if anyone has any other questions or if they'd like to talk directly to us. And we are available, of course, so you can follow up with us. Our emails, myself is Jones, Jones, at PCIGeomatics.com, and Sean is last name Melamed, so Melamed, M-E-L-A-M-E-D, at PCIGeomatics.com. And we have one more question here that just came in. I'm not sure if you see it, Sean. I think it relates again to changing the pixel values with cloud coverage or shadows.
How is the function? Well, like cloud cover, the mosaicing,
I think the
that's a question we're going to have to probably
the,
get back to, yeah.
Yeah, I think it relates to the copy-paste function, and when we brought, an image without any clouds and whether the DN values were different. So I think the answer to that is yes, absolutely they're different. They're from a different data set. But we'll definitely follow up. And if we haven't answered your question, feel free to send us an email and we'll do our best to help you out. So with that, I'd like to wrap up the webinar, and thank you so much for taking the time out of your busy days to spend some time with us here to learn about our technology. And if you have any questions whatsoever, you can contact us. You can head to our website. You can find us on social media, Twitter, Facebook, YouTube, etc. Feel free to reach out anytime. And once again, great to have you today. Have a good rest of your day.